Today on Transmission Tech with Power Driven Diesel, I'm Dustin.
I'm Will.
I'm Dustin.
I'm Will.
I'm Dustin.
I'm Will.
I'm Dustin.
Welcome to Power Driven Diesel. Today we're talking about torque converters. We got billet converters. We got stock converters. We got fat shafts. We got quad disc. What was that? Holy.
That was kind of scary.
That was Dustin, you're like,
I'm backing over. I'm getting over here before I get hurt.
Okay, so this video is pretty specific to 1994 through 2007 Dodge diesel automatic transmissions. We get a lot of guys say, hey, I've got this converter from a 47 RE. Can I put it in my 48 RE? Well, in the first video you learned 2003 and up is generally 48 RE, 2002 and older, 47 RE or 47 RH. Tell us the main difference in the pump. These are pump stators, Dustin. What's this one on the right here?
48 RE. We've got the notch for a seal, and that reacts inside the torque converter, and this is a 47. No groove. This is an updated stator support for 48 specific.
So inside the torque converter, a 47 does not have the ability to catch a seal. A 48 does. What this does is it raises the efficiency of the converter just a tiny bit. We noticed the pressure that gets trapped in the converter is a little higher. It makes them run tiny bit. So it's just a small update the factory did.
Slight efficiency upgrade. Few PSI. Just a little bit of loss there, and it's usually on, say, an older worn transmission with a bushing.
So most performance automatic transmission builders, they simply remove this seal from a 48, and then you can put whatever converter you want in there. It doesn't hurt to leave the seal, but if you have a 47 converter on a 48 stator and the seal is there, there's a chance that seal could pop loose. It's just Torlon plastic, and it could eventually block something in the valve body and cause an issue. That's the only downside, really, other than the tiny efficiency loss.
Obviously, all the older ones, they operate just fine. It's just a little update. So
the 47 is compatible. It doesn't care what converter is on it. Just like the 48 really doesn't care, other than if there's nothing to hold the seal, you probably shouldn't leave the seal there. Inside the converter right here, you can see you get down here. What did we decide that was? About an inch and then
1.3 inches.
1.3 inches down. The inside diameter gets bigger on a 47 converter on the snout or the nose of the converter. So you can see right here, right there, it gets bigger. On this is a new DPC converter, and when you pull the top off there so we can look in there.
On this one, you can see that it's a smooth land all the way down until you get into the stator and where your bearings and everything are.
2 or 3, 2.5 inches or so in there.
Yeah. But that 1.3 inches down there, it's just a continual slope. Straight, nice straight edge.
So that's how you can tell at home what converter you have. Reach your finger in there. If you get down about 1.3 inches and it gets a little bigger, you can feel a little lip. It's a 47 converter. It's smooth, it's 48.
Yep.
Pretty simple. Something else I want to tell you about converters. You look right here, there's little angled grooves right here. See how these are more flat and these ones are a steeper angle right here? These flatter ones, this is actually a V10 torque converter. So this is out of a V10 gasoline application. This converter right out of the factory is about 2,400 RPM stall. This diesel one is about 2,000 RPM stall. Now stall is kind of like an arbitrary thing. There's like a flash stall that the torque converter first goes to, first time you whack the gas or you step on the brakes. And then there's a true stall, which has to do with a K factor and has to do with how much torque the engine can make at a certain RPM, and that's how hard it will push up. So basically you stand on the brakes, you floor it, and the RPM slowly climbs. That's kind of how you measure the true stall. Kind of hard on it when you do racing. That's how you build boost so that you can launch hard at the starting line. But just really quickly, just something to notice, if it has this is a V10 pump. This is a diesel one. So if your converter has a little bit more vertical groove here, it's probably higher stall. So if you have some random aftermarket torque converter, you have no idea what it is, that's a key indicator there that'll tell you it's probably higher than stock stall. Now there's 2 other components in there that affect the stall speed, so that's not the only factor, but that alone is worth a couple hundred RPM of the stall speed increase between a V10 and a diesel torque converter.
Yep. And then as far as core usage goes, if you're concerned about that aspect of it, the racer guys like us here, we use a V10 stall or higher quite often. So if you're wondering if your gas or torque converter can be used as a good core, say for your diesel torque converter that you're going to be buying, we'll take them.
But it needs to be a V10 gas, which will look just like this. You get into a 518 or a non-lockup, the converter's different. Not nearly the core value. So you really really the only gas would be a V10 Magnum, gas application. Big block.
Yeah.
So a little bit about torque converters. These are both stock converters. Let's flip this up here. And you can see stock converter has these 6 welded lugs on here. It's a stamped steel cover. There's a clutch on here that applies against this back cover. And a stock one is a little bit prone to warping. You get a lot of apply pressure in there, and they can warp when you get like an aftermarket valve body. Tip up that DPC converter for us so we can see.
And this is a aftermarket billet cover, which is this one. You can see it has 12 bolt holes. That's a new upgrade that we are now selling, right? And that is mostly for these racer guys. If you ever have a flex plate bolt come loose, it will chew these all up. And so you can shift it one hole over, because you only use 6 bolts on your flex plate. There are 12 bolt flex plates out there. It's just
They're a pain in the butt. I hate them. Don't get a 12 volt flex plate. But if you do, it's fine. Just use 6 of the bolts. So if you do get one boogered up, you can rotate them one hole
and still use your torque converter and not throw away your $1,500 raised quad disc that you just bought. So
one other thing, notice on the billet one, this back cover is much heavier. The torque converter itself, they weigh, about 20 pounds more roughly. There's that much more steel in them. This big heavy back plate, that's what gives them the strength for the clutch to apply. So then we're going to talk a little bit about single disc, triple disc. What does that mean? So a lot of people think a torque converter is kind of a mystery. They don't really understand how it works. There's kind of 2 main components on a Dodge diesel torque converter. This is also same for like a Ford diesel, Allison, all these heavy duty, high performance things. The torque converter has a lockup clutch in there. What happens when you're sitting at a stoplight, the lockup clutch is not engaged. That's why the truck can keep running and the car doesn't stall. Once you're moving, that torque converter does some fluid coupling. So in this part, it's almost like a series of, you can think of it like fan blades, and fluid pushes on a turbine, which is splined into this piece here, and this piece here is splined on the input shaft and it turns it. But it's all from fluid pushing on fan blades. When the valve body commands lockup, that's when you want maximum efficiency or maximum power. There's actually a clutch that engages inside that is splined into this same thing, and it literally applies a clutch against this back cover, which is bolted to the flywheel. So basically, or the flex plate. So basically, all the power from the engine gets transmitted into this through a clutch, which gets transmitted directly in the input shaft. There's 0 slip. So automatic, when it's in lockup, has 0 slippage anywhere. None of the clutches, nothing is slipping. So a lot of guys think automatics are inefficient. Well, when you're at a stoplight pulling away, yeah, they've got some slip built in. But once it's locked up, there's no difference between it and like a manual transmission as far as the power that gets to the ground.
How I like to always envision it is it's a 1-to-1 output ratio when you are in lockup. So if you look at your torque converter, basically this side's bolted to the engine, and that's input, right? And then your transmission input shaft is here coming out of it. So you have your input to your torque converter and your output to your torque converter. So there's your slippage in between the two, and when you lock up, you got
between the torque converter and the transmission, that's where all your slippage happens. Okay, so we have a little treat for you. Not a lot of places have cut open torque converters. Well, we have a cut open quad disc from DPC here, so that you can kind of see what this clutch assembly looks like. Essentially, the clutches are these big monster things. These get applied against that billet back cover. There's this ginormous pressure plate here.
That was a good catch.
So basically, these clutches are splined. You can see on here, this floater plate is splined. And then there's another clutch here that's splined. And this whole assembly presses down against that billet cover. Now you see it has some splines here in the middle. These splines, once again, are engaged on this input shaft. right here, and that's how all that power gets in there. So when you have a triple disc, that's the other thing that's a little funny about torque converters. They kind of cheat. When they say a single disc, they literally have a clutch like this bonded to the metal plate, so it has one surface that applies for lockup. That's a single disc. A double disc has a floating clutch that has two sides, so you have two friction surfaces that get applied. A triple uses three.
And what is the benefit to having multiple surfaces?
Multiple surfaces, you can hold more power. I mean, it's just pure about torque, how much torque this clutch can handle. Now, one other thing, this is applied by line pressure. Line pressure is the hydraulic pressure the transmission makes. So when your transmission, a stock valve body, makes 90 psi in overdrive, there's 90 pounds of force pushing on this hydraulic assembly to apply this clutch. It takes a lot of force to make it slip when there's 90 pounds per square inch times that whole area. There's a lot of force on there.
So
you get three clutches in there, that same 90 psi now makes 3 times the amount of force, or 3 times as much torque to make it slip. So that's why they want the triple. There's more area to wear, so it lasts longer, and the load's divided up by 3 surfaces.
So when I've got my 4 dirt bikes piled on the back of the trailer and all that power, and I'm cruising down 80 miles an hour down the road, it's all going through one surface on a single disc.
Correct.
That has to hold all that power and torque. That's a lot of power.
And every time you hit a hill and you step on the throttle, it'll unlock the torque converter. Then it's on the stall part of the torque converter, or the turbine side. And then when it's locked, it's got to soak up that 2, 3, 500 RPM difference. So it has to deal with a lot more. Once it's engaged, it'll actually hold quite a bit once it's locked up. Now, if you get a single disc and you start making a lot of power, you turn up the power in your Cummins, you start feeling a little rumble or vibration, that's you actually slipping the lockup clutch usually. And on your single disc, it's common. On the triple, it takes a lot of power to slip a triple. Now, this is a quad because there's technically 4 friction surfaces. Only 3 of them are active. So really, when we say quad disc, they're it's kind of a gray area. It's quad in essence that there's 4 frictions. It's heavier duty than the triple because there's more steel here and there's thicker, fatter frictions. But technically, a quad disc really only has 3 active friction surfaces. But rather than saying it's a super heavy duty triple and a regular triple, they're calling it a quad disc because technically it does have 4 friction surfaces, but only 3 are active. That's just kind of a little quick tidbit. So we get a lot of guys calling in. They want to know what's the difference between a DPC triple disc and a DPC quad disc. A DPC triple is a lot like the other brands of triple disc. I'm not going to name all, but there's several other manufacturers that make triple discs. They have a little bit smaller frictions in these. They're thinner, and the diameter is a little bit smaller. And they basically have one 2-sided plate like this that's a little bit thinner, and then they have a bonded friction on the ply plate. The DPC has this floater plate plus another 2-sided friction. So this is what you pull that out. So this is what you get on the quad. Truth be told, though, only 3 of these friction surfaces are active. So it's not technically correct to call it a quad, but it is heavier duty than a regular triple. So it's what do we want to call it? A super duper triple? I don't know.
Call it a quad because if everybody communicates and they all know what you're talking about, it stays on the same page.
It's quad. That's what we call them. It has 4 friction surfaces. They're a little more serviceable. That's another reason Phil does it for the kind of racer hot rod guys. With that extra surface in there, it protects one of the plates. It's a lot faster turnaround for him to service it when it's a quad versus a triple, because it doesn't nearly do as much damage to the billet cover and some of that.
So when do guys go to a quad versus a triple? I have a feeling we're going to have a lot of guys wanting a quad because it's going to be better, but there are some downsides to them also. Usually
around 1,200 horsepower is when we're thinking about it. A triple will still hold that. The main thing on a quad, they have a non-dampened stator. So in the middle, on a factory triple or single disc or a triple disc, there's springs, and this whole plate has give built into it. Makes it engage a little softer. It's a little easy on your shaft. This also, because it doesn't have any sprung plates, these are a little more prone to rattling at idle. They're a little more noisy, kind of like a double disc clutch for a manual transmission. You know, like a really aggressive sled pull. This is kind of like a really aggressive sled pull torque converter. So if you want really smooth, quiet, the triple is definitely a better match for you. you want the thickest, heaviest, gnarliest, most abused torque converter you can get, that's when you play with this quad disc. One other thing we've noticed with the quad disc, they're a little bit more finicky if you have a weak transmission pump that doesn't have good release oil coming in here, a little more prone to dragging. So if you can have an old clapped out transmission, this really isn't the torque converter for you. A triple is a much better option.
When do you get guys into a triple disc, horsepower wise?
Usually when we go to our 485 horsepower tranny, that's when we're going in the triple. And it's really, horsepower is kind of it's the way the industry does it, but really it's a torque thing. You get about 1,000 foot-pounds of the tire, and it will slip a single disc. There's not enough clutch surface there to handle it. And it might handle it short term once it's locked up, but if you're hauling and towing with a single disc, you get up there even, I'd say much over 800 foot-pounds, and you haul with it regularly, you're going to be blown right through that single disc, no problem. I mean...
And once again, that's relative to your pressures that your valve body or your transmission's commanding.
Yeah, because if you have a stock tranny that makes 90 in overdrive, or a power-driven valve body that might be anywhere from 150 to 200 psi, you're getting twice as much apply on that single disc. So that's why we can kind of extend that range. Like that 425 horsepower tranny we sell, it has a single disc torque converter, and it is sufficient for that. However, you can make 425 horsepower with compound turbos and make 1,300 foot-pounds. We've done it before, and it will slip a single disc. So horsepower is kind of a sales point to help people understand, but really torque is really what tears this up. If you're making a lot of torque, you're loading the truck heavy, you really want a triple disc.
Yep. That's the only thing I'd ever put in mine if it's torn apart. It's not worth the hassle. That's the whole reason mine got rebuilt in the first place, is because the torque converter started slipping. So there you go.
So basically, I mean, just a little quick recap. Stator seal 4748, they're reverse compatible. This seal can come out if you put a 47 converter in 48, so be careful there. Anything else we wanted to just really hit on lastly?
I think we pretty much got it. I mean, you guys should be able to identify your torque converter now and give us a good core if we need one, or if you need a core credit, and you'll be able to know what you want mostly.
Let's talk a tiny bit about stall speed. Guy, we've been really missing out on that.
Yeah.
So stock is about 2,000 RPM. You got to remember, stall speed is based on the power the engine's making. You turn up the power on a stock converter, it might stall to 2,400 when you're at full power. So stall speed's kind of like a moving target depending on how much power you make. However, if you have a big truck with big turbos and you get a really tight, efficient torque converter, it has a hard time getting enough RPM in the engine to even get the turbos lit. It'll make the truck a smoky, lazy mess. So torque converter stall speed is a really exact science that the factories worked really hard on to get dialed in. And the stock ones work great for stock power. You turn up the power, you want a little bit more efficient converter that's a little bit tighter or lower stall, meaning it grabs the engine earlier, or the engine can't push through it as much.
When it's unlocked.
When it's unlocked. When it's locked, none of that matters. It's all locked. They're all the same. So really, this is just the pull away from the stoplight power, the how well you can brake boost and build boost if you're racing. You're going up the mountain when it kicks out of lockup, and your RPM goes from 2,000 to 3,000 RPM if it has a high stall, or if you have a tighter stall, it might go from 2,000 to 2,500 when it unlocks the converter. All that plays a factor. But what's the most common stall speed like 90% of people buy?
We sell mostly a 200 under, which is an 1,800 RPM. A lot of guys...
So it's a little more efficient than stock, but it's not so tight that you can't get your turbo lit.
You can't get it going. It's all, and once again, it comes into your driving style and how you like your truck. And you know where your truck runs. You know how fast you run it down the freeway, RPM-wise, or pulling away from the stoplight. I mean, you know what you feel like, say, my truck or your stock truck. If you take a stock truck, it feels like a slush box to me. Just too much RPM, not enough hookup. You've got the power there, but you're not getting it to your tires. The little bit tighter stall, this is why we sell a lot more of them. It gets rid of that.
Feels way better.
Yes, it feels much more solid. The power's being transmitted.
My truck, my daily driver with compound turbos, if I have a trailer behind me and the converter's not locked and I'm accelerating up a steep on-ramp and I've got my foot in it, making 500 or 600 horse, it feels like even the tightest stall converter is too loose. I want to get on that lockup switch and get that thing locked up, so I'm like, man, I'm not going anywhere. I feel like I can't accelerate. but I have a lot of power. You know, you get 500 or 600 horse, I might have 1,200 foot-pounds running through that torque converter. It was never designed to do that in the unlocked position, and so it just feels slushy and loose. I take my other daily drive. I have lots of daily drivers. Sorry. Take my other truck that has a single turbo, fuel plates pulled out of it, AFC Live, a couple little mods like that. The 200 under feels great. I tow with it. Feels awesome. I'm not reaching for that lockup switch, but it doesn't make 500 or 600 horsepower, so it doesn't feel like it's a slushy mess when I'm going there. So stall speed's kind of all relative. Really, it depends on what you're doing. If you're racing, you want the stall speed as tight as you can make it and still get your turbo lit at the starting line. If you're hauling cattle up the mountain, you want as tight as you can tolerate from the stoplight, but still get it going, because when it unlocks the converter on the hill, you want that lower stall so it doesn't rev really high. Or you need a lockup switch, so you can be really careful. You can force this clutch to lock up whenever you want with a toggle switch.
So the best feel, if you're going to get a new torque converter, a new transmission with us or anybody else, just feel how you have your torque converter now. And if it feels like a slush box, then you know you might want a little tighter. If it feels like it's already tight, go a little bit looser if you got that power there. So there you go.
You get a truck with a big single turbo, we get lots of guys calling that, you're going to want the 200 overstock minimum. That's kind of a, you know, that 2200. Some guys that get a big single, like a 76 millimeter turbo, they want like a 2400, like a V10 stall. So that's why they make all these stall speeds. Our big UCC race truck, it has a slut converter. It's about 3200 stall. So it just depends on what you're doing with it, what you do on the stall speed. But that's the magic side there. The clutch is the other magic on holding the power. And beyond that, they're really not that complicated inside. They're just a mechanical, man-made device that helps you get power to the ground.
There's lots of math and engineering to them, but we better get a torque converter guy to hear if we give it a little more detail on that. I think we went detailed enough this far, though.
Anyway, thanks for tuning in. Like, subscribe, follow our channel, and stick around. Next time, I don't know, we're just going to keep talking about transmission stuff. Anything you want to know,
Put it in the comments.
Yeah,
And
if you want to know something, you want to know what the difference between a 48 Planet and a 47 or a pump or...
Basically, we don't know what the next episode's going to talk about, so the more hits we have on the comments, we'll hit those on the next.
Thanks.